I'm going to build a small IoT application that collects data from a Modbus PLC and displays it on the screen. When you start MIStudio and add an application, you're presented with the design window. The design window is where you build your GUI, whether that be a front panel GUI or whether that's a GUI that's going to display in a web browser. When the design window is displayed, the top panel also displays graphical components. So you have a whole selection of graphical components, including the basic layouts, but everything up to and including alarming and charting. For this application, I'm simply going to take 3 annunciators and put them on the screen, and this will be my entire graphical user interface. Associated with every MIStudio design window is a diagram window, and the diagram window is where you build the logic that backs up the design window. To do this, I need to move my components to that diagram window, and for that we have a menu item which is Edit Copy to Diagram. There is also a hotkey which is just Control D, which takes those components to the diagram window. As soon as I move to the diagram window, the palette changes from being graphical components to being logic components. This includes some simple data sources, which are just used for demos and for indicators. But it also includes a complete suite of components for reading PLCs and also database access, IoT protocols, and the ability to push to the cloud, Amazon Web Services. Quite simply, this works the same way. I click on a component here, and this is just simply a counter, and I drop that on the screen. Now I have my counter is on the screen. I also have a representation of my component from the design window, and I can simply hook these two together, and we'll see that the component on the design window begins to update as soon as those two are hooked together. To do this for a Modbus PLC, all I have to do is click on the Modbus tab, and all the PLCs work in a very similar fashion. I drop a component on that represents the PLC. I need to put a host name in here for the PLC. So host name or IP address. And so this is now my representation of a PLC. To read from this PLC, I put any of the registers on there. We'll just take an integer register. I associate that with my PLC, and I put a register in there, so we'll read register 1. And I put a time base in here. How often do I want to read that register? Then just as simply, I connect this to my annunciator, and we'll see the value from the PLC. In fact, when MIStudio starts up, it always starts up in simulation mode, so there's no danger of you accidentally writing to your PLC and causing some problem with your process. You have to actually go into live mode by pressing the global simulation button to get the real value from the PLC. I'm using a simulator here, and we see that in fact that is our 4001 register is 15. I can also write to a PLC. I can do this quite simply by adding a PLC register on the screen, and then I can take whatever I want to do to write to that. Now this could be a component from the screen. I could put a text box on the screen and be typing these values in. I could be putting a push button and starting and stopping a process. Or I can take a component off my palette, any component. It could be from a database. It could be anything similar. Here I just have just a wave, just a moving wave. And I connect that to my Modbus server. You'll notice that I got a red connector here, which means that something went wrong. It didn't write to that PLC. And the reason is I have not yet configured this. So I need to choose my device, and I need to choose my register. So we'll write to register 2. And I don't need a time base because I'm simply writing to this device. Once I do that, the connector goes green and everything is correct. And if I look at that value now, we see that it's incrementing in the simulator. I can read this device by just dropping a component on the screen again. And we'll read that same register. Let's read that every second also. And so now we're reading the value from the second register and displaying it on the screen in the middle enunciator. And that's really all there is to it. Because we're working through this Modbus device server, these reads are all smart. We're not reading each one of these individually. They're all being blocked into the maximum block size that a Modbus package will allow. So if you're reading multiple Modbus registers, we're going to try and make the biggest packet we can to read those as efficiently as possible. There's no reason for you to be involved with that. That will just happen automatically in the background whenever you put these components on the screen. To complete this application, all I'm going to do is I'm going to deploy this to my IoT device. My IoT device is actually a Raspberry Pi in this case. But anything, we support a wide range of Windows and Linux IoT devices. Again, I need the IP address or the host name of that device. Once I've done that, it's simply a matter of deploying this to the device. Once the build is complete, we're presented with the option to browse to that application. And here we see our application running through the web from our IoT device.